Hello everyone, this is Aravind Vankadaru, currently pursuing construction engineering management of third semester. As part of the studio integrated construction practices, we are looking at a mixed development project. As of this studio concerned, we are going to deal with a mixed development project. This project is located at Ambli, West Ahmedabad. This project is covered in the area of approximately 15,200 square meters. The project contract type is item rate. The approximate cost of this project is around 250 crore. As of this studio concern, I'm going to be acting as an architect as well as an electrical consultant. I will be dealing with LOD 300 architectural model, 400 architectural model. Along with that, I will be dealing with the process mapping, quantity takeoffs. Apart from the architectural models, I will be also dealing with LOD 300 electrical models also. This studio scope we considered of a block D and D out of block ABCDE. For the block D and D, we are going to deal with third, fourth, and fifth floor. Architect design process flow map. So, as of this flow map concerned, it has been divided into five different stages. Initially, setting up the master template for the team. Later, LOD 300 modeling has been done. This model have been gone through an class detection, class resolution process for this. Later, after the class resolution, this model is further developed for the LOD 400, adding all the parametric values to the model. Later, this LOD 400 model is also undergone class detection with various consultant models. Whereas coming to the workflow, the initially AutoCAD drawings have been received from the site, and these drawings have been imported into the Revit architectural template. This template have been used for the architectural model. Along while working with the 3D model, Lumion is also being used simultaneously to visualize better. After the completion of Revit model, Naviswork application has been used for the class detection and class resolution. The time difference between the Revit model using the Naviswork for the visualization as well as the Lumion was approximately 14.5 minutes. As of the architectural workflow and render being concerned, initially project base point have been chosen in the big room meeting. This base point have been first created on the AutoCAD. Later, this base point is also being imported to the Revit. After this, GFC drawings have been totally imported into the Revit, and setting up the planes, floor planes, floor plans, and everything has been done. Later, 3D components such as walls, windows, ventilators, doors have been created. Along with that, later ceiling is also being created, POP. For this, electrical consultant will be able to put all the electrical fittings, fans, and lights to the ceiling. LOD 300 model is totally completed along with this. Extra parameters and extra detailing have been assigned to these things for LOD 400 models, such as plaster detailing and doors and windows detailing. Onto the left corner, you can see the living room and kitchen dining renders. During the architectural model development, I have found the several constraints. One of the constraint is varying depth of floors. You can see on the left side corner where there is an sunken slab in the washroom area. There is a 6 mm offset for the structural slab, and at one place you can see 75 mm offset. So there is a complexity here while modeling. Onto the right side, you can see various complexity of building architectural walls due to varying beam depths. You can see there are various types of beams, dimensions located at one single junction. Onto the right side corner, you can observe 600 mm, right, 750 mm varying depth of beams. Due to that, while modeling these walls, it's being difficult. These are some of the constraints in architectural model. Progress tracking for the architectural model. For this progress tracking, you can see on to the left side there are various WBS codes have been allocated for LOD 200 to the LOD 400 models at various plan dates. Onto the right side, you can see the percentage plan complete tracking. Onto the right bottom corner, you can see the PPC graph varying from 100% to the 60% in the week 7. Again, there is an increment to the 100% to the week 9. This change variability has been observed most in the week 7, which is 60%. The constraints were, one of the constraint is knowledge of the material and specification during LOD 400 was not clear later. And one more thing is design complexity have been much more increased when compared to the LOD 300 model. The other constraint was during the week 7 there was an clashes with the class resolution 1. During this class resolution, it has been taken time for resolving the clashes with the structural model as well as the plumbing and electrical and mechanical models. Looking at electrical model workflow, initially the floor plans for the electrical model have been created. Later, EFA PEL plugin have been installed for the switchboard sockets, switches, regulators, and all. Lighting, all the round lights for the ceilings have been imported. Conduits also have been modeled into the model. So combining all these, electrical model is prepared. Onto the right side you can see a section view of a bedroom where conduits have been placed and lights are also being done. The workflow for this electrical model is shown to the extreme right, where from AutoCAD to the Revit to the EFA-PEL plugin have been used, and later this model have been undergone to the class detection and class resolution process. Coming to the constraint analysis of electrical model, so onto the left side you can see on-site comparison to the electrical model of Revit, where you can see the conduits, how it has been plastered on site and how it has been modeled in Revit. Into the center you can see the complexity at distribution board, where different conduits are meeting at one singular place. Due to that, while modeling at a large scale using LOD 300 model, it was so complex and it was so complicated to this model. And to the extreme right you can see there are various junction box and there are various conduits meeting at one particular place. So here we have compared with the on-site and the model where the conduits are meeting at one singular place, and how we have been modeling at Revit. Virtual reality and augmented reality. This AR/VR is being done using parametric model. Initially, parametric model is being extracted through the Revit, and using the plugins such as Prospect VR and Visual AR helps in utilizing these parametric models for the of BIM. These models have been uploaded to the cloud storage to multiple accesses at multiple points at sites and offsite. So these can be accessed remotely, as we have been discussing. So the advantages of AR/VR are one of the important thing is walkthroughs can be shown to the clients, contractors, as well as the site personnel for the better visualization and better understanding. A collaborative approach can be formed on site between the teams. Remote works we can see between the consultants, where there are various consultants nowadays out of station working for this project. They can access to the site and they can better understanding of site problems and the clarifications required in a better manner for AR/VR, using AR/VR. So ideas sharing is also being done, and inputs can be gained from various teams using AR/VR model, as they can understand better, as they can give an output better. So for the clarifications also, site personnel can immediately send their doubts to the consultants, where they can review and they can give the reply on site immediately. As we have known that these models are parametric, information can be accessed very easily. To the right side you can see AR model which is being placed on an scale level of an architectural model. To the right side you can see the model element properties, where each element can be selected. Onto the extreme right we can see the parameters, the thickness of the plaster, the height of the wall, the location of the wall, everything. To the left bottom, you can see the estimated cost of this AR/VR implementation was approximately around 5 lakhs. There were two one-time investments, such as one computer as well as VR headset is a one-time investment, where there is a monthly, yearly subscription for the Prospect and Visual Live applications. To the right side, you can see there is an BIM model which is being augmented on site. Using Visual Live plugin, this model 1:1 structural model is being augmented. To visualize these augmenting BIM model parametric and element properties, scan this QR code which is available on screen. In the, Now we will be looking at a difference between the traditional approach as well as the IPD approach. For the traditional approach, current practices have been observed on site. So quantities were taken using Excels. Data is being stored locally. RFIs have been raised but shared through the mails. 3D model is available but only used as an visualization purposes. One person responsible for taking decisions. There were multiple revisions but there were no clarifications. There was a monthly planning involved, which involves the contractor as well as the client. There were no clash detection prior to the execution. 2D models, 2D drawings are used for the site layout optimization purposes. IPD approach is quite different from the current practices where parametric BIM model is used for the quantity extraction, which is being done with a single click. Data is being stored cloud, where all the consultant as well as the contractor and client access the data at any time. Big room meetings have been conducted in this IPD approach where RFIs are being reduced drastically. Interactive models such as AR, VR helps the site personnel to access these models on site to visualize 1:1 model. Risk distribution have been done in sharing in between all the consultants, contractors, and clients. So collaborative approaches helps in reducing the revisions, and the quality of drawings is also being improved. LPS system involves monthly planning for look ahead planning, weekly planning, day-to-day planning. Clash detection is being done prior and clash resolution is also being done using Navisworks in IPD approach prior to the execution. Site layout optimization is also being done using 4D simulations using Synchro. Coming to the conclusions, this studio integrated construction practices deals with adoption of IPD approach for a successful project implementation. A direct comparison between the IPD versus traditional process is being shown. The traditional system being hierarchical, whereas IPD approach taking into account for importance of collaboration in the field of architecture, structure, and as well as MEPF. The studio focused on working on a small scope, which we have seen for block D and E 3, 4, 5 floor. This scope impact can taken into the project level slowly. In the field of BIM process adoption, the studio gives a deeper understanding into BIM as well as the lean approaches, which will be in future demand in the industry.